Hi everyone. Today I will be talking about the 2D game example included in the toolkit. It's called Hydrous layer. It looks like this. This was an attempt to show how the toolkit can be easily adapted to make very different sorts of games, not just traditional turn-based strategy as you might get the impression just from seeing the base game example. This is more of a dungeon crawler, similar to a roguelike sort of game. And it uses sprites and tile maps and a few tricks to make a very different, sort of single player dungeon crawler experience. Now, for those of you who haven't tried it out, I'm going to now just play a few turns of this so you can see how it works. So, the first thing you'll notice is the music playing in the background, which is made by the very talented Jon Lunde. You can freely use this track in your games if you want to. There's a link to more of his work below this video. Also, for the tiles that are used, all the sprites, they are not made by me. These are Creative Commons assets that are available for free online and part of the RL tile set. And there is a link below also in the description to get those awesome tiles. They can be used freely without attribution in any of your games, but I have not made them. Another thing you'll notice is that there's a fog of war effect. Not all of the map is revealed at once, as you can see. And we can also move without going over to the AI's turn. So it's the player's turn until we see an enemy, at which point we enter turn-based combat. So when I exit this door, you will first see that we reveal more of the map based on where we're standing, and also combat is initiated, at which point we get this frame to represent where we can move. And I can split up movement here, and then click to attack. And it's made to be very swift and simple here. So, and they leave little bloodstains, and then we're back to freely moving again until we enter another door, at which point more enemies are revealed. So here we can see the ranged AI, so he's moving away. Also, they don't react the first turn they see you. That's the thing I've added, though there are some charging minions later that can attack you even at the first turn that they see you. Let's see. So we're getting pretty low on health. Good thing there's a potion here. So we've also shown in this example how you can include items and such in your game that can be picked up. So we're at full health. Before we exit here, let me show one more item. See, I can't reveal all of the game. I mean, it's fun to try it for yourself. I've made it fairly challenging, so you might have to try it a few times. This is a good opening though. Yeah, there's the sword. So there's also a rudimentary equipment system. So now I will do more damage than I did before, twice the amount. There. So yeah, that's the basics of how this 2D game works. So let's look a bit more on how I've made this work under the hood and how you can replicate it yourself. So this map can be found inside Maps, 2D game example, and here is the map called Hydrous layer, because, well, the boss is a Hydra, that's a spoiler I guess. There are folders here for blueprints, sound, sprites, textures, and tile maps, and the blueprints are, for the most part, child actors of actors contained in the main blueprint with added functionality. So that's where we should start to take a look to explain what's going on here. So entering blueprints, you can see if you already, you have the game mode 2D and, well, the blood blueprint for these blood spatters, different camera for 2D movement, a grid manager 2D, this is where most of the stuff is added, or most of the gameplay functionality here. The HUD, well, a tentacle, and a torch. These are just small, simple blueprints for some gameplay specific stuff. I would like to add that most of the blueprints here aren't as polished or as generally useful as the ones in the main toolkit, and that's because when I'm making stuff for the main toolkit, I have to take a lot of stuff into account. I have to think all the features I add have to be usable for height maps, for hexagonal grids for all sorts of different things and different ways that people can use the toolkit, and I try to accommodate all that stuff. That takes a lot of time. If I was to do that for all such game examples, and I intend to add more, it would take a lot of time for me to add this. So this is a bit closer to how you would do it if you were making an actual game, where you don't need to take account into all of these things, and some things can be a bit more hacky and so on, and specifically made for the game that you're making. So with that in mind, let's look at the different blueprints. Starting on the left, we have the game mode 2D, which is very similar or identical to the regular game mode, only it has different default actors set up. Then we have the blood blueprint, which is a very simple blueprint that just sets up a random sprite from an array to display as this actor's sprite. So that's just to add some variety. We have a few different blood spatters. So event begins play, that means when it's spawned, we set the sprite, this main paper sprite, to a random integer from this sprite array between index 0 and the last index, which makes it a random sprite. Then we have the grid camera 2D, which is very similar to the regular grid camera, only with a lot of stuff removed. So we just have panning, we don't have zooming, we don't have rotation, since that's not used in this game, and the camera is orthographic instead of perspective camera, which is better suited for 2D games. Then we have the Grid Manager 2D. Let's get back to that one since it's a bit more complex. The Dungeon HUD is, well, it's a pretty simple additional HUD that just displays game over, which we can call when we want, well, the game to be over. The Tentacle. Talking about lack of polish, this should have been removed. I'm using an actor instead now, or I mean a pawn instead of this actor, so this isn't actually used. Oops. Then there's the torch. So you have these torches placed around in the game, and they can be lit. In this game, when you step on any of these triggers, they are lit, and when you light all of them, then this bridge over the lava pit here opens up and you can go to the final boss. So the torch itself is pretty simple. You have this light torch event, which can be called from outside. When it's called, the sprite that shows an unlit torch is set to invisible, and the sprite which shows a lit torch is set to true or visible. And then a sound is played of a torch being lit. So yeah, let's get to the Grid Manager 2D. So here's the event graph. Let's start on the top left. So first, when the event or the Grid Manager is activated, we run all the nodes that are usually run in the Grid Manager. Then we do some additional stuff. First, we add this Dungeon HUD to the viewport. Then we add an instance of the Fog of War instance. Now this is the mesh, which is just a square that is put on top of any tile that we haven't discovered yet, so that we cannot see it. And it's just a simple UV plane. And then for each index in the entire grid, if you recall from previous videos, the vector field array is an array that is the size of the grid, so the size x of the grid times the size y of the grid, which contains the locations of all the different tiles. So if we loop through this, we get all our tile location. For each tile location, we want to add one of these Fog of War instances on top of it. So we add 1 to the Z location so that it will be above the tile map, so that it will cover it up, and we add a lot of these instances. You use instance static meshes and not regular static meshes, as it's much more efficient. Then we have this Fog of War array. So this contains, or it keeps track of which tile indexes have been discovered and which have not, for gameplay purposes. And it is the size of the grid as well. Then we get a reference to the game mode. We cast it to the ATBTT game mode, since the game mode that we're using, the 2D game mode, is a child actor of the regular game mode. We can still cast to this game mode. We clear the initiative order array, since by default all of the units that are in the that are placed in the game are added to the initiative order. But in this game, we just want the player to be added to initiative order, and then the other units it encounters to be added to the initiative order as they are encountered. If you were making this game from the ground up yourself, and then you could just go to the game mode, of course, and just set it up so it's like this from the start instead of overriding it afterwards. But when I'm making this example game, I don't want to touch any of the regular blueprints, so I'm overriding it in this sort of awkward way, but it works well. Afterwards, I get all the actors of the class Hero, so this is a different new unit that is made for this this example map. I'll get into that one later. There should only be one, and so it finds the only one that is here in the game, and then it adds it to the initiative order. So at the start of the game, the only unit that is in the initiative order is the player hero unit. And then it sets free roam to true in the game mode, so that you can move around freely without being split into turns. I might not have covered this in previous videos, actually, that I have added this free roam mode, so that you can walk around like in the old Fallout games or something, and then when battle commences you go into turn-based mode. I'll cover that later, but it's basically as simple as activating this free roam mode, and it works well. Then we get all the widgets of the HUD faction turn class, and we set the turn text, the one that says player turn, enemy turn, and so on, to hidden, since we are not using that in this game. That's the first part of this blueprint. For the second part, I'm overwriting a part of the pathfinding in the game. So if you've watched previous tutorials, you can see that I've made this option of having different custom pathfinding options for different units. And in this case, I'm just using the basic custom one option. Like I've said before, you can add as many new pathfinding variants as you want. But in this case, I'm just using the basic custom one, just to make it easier to implement quickly. So this is almost identical to the regular pathfinding. The only difference here is that when searching through each tile, it looks to see what is it looks at the fog of war array for that tile, and then it sees, is it true or is it false? By default, all of it is false when you generate the map. So false means that a tile has not been discovered by the player yet. So that means that if it's false, we should not be able to move to that tile yet. If we haven't seen it yet. So this is all this does. And in the player unit, we make sure that his pathfinding is set to custom 1. While for all the enemy units, I want them to be able to move through the fog of war. So they just use the regular pathfinding instead. Let's go to the next part of the blueprint. Let's see. Yeah, this override I'm actually not using anymore. I used to set up a reference that I used later, but yeah, I don't do that anymore. So like I said, not quite as polished. This isn't actually used. This is an override for the set marker location function. It's very similar, only that the Z values for where the tiles, the markers are placed are slightly different, so that they will always be above the tile map but below where this or how high the sprites of the units are. So yeah, that's very similar. That's it for the Grid Manager 2D. The next blueprint I want to look at is in the Pawns folder, this Unit Parent 2D. Here you can see quite a few of the wonderful sprites that are from this FL Tiles Creative Commons free sprite pack, by the way, which are available for commercial use. So that's an incredible gift from the people who have made these things to all developers. Link below, like I said. But yeah, Unit Parent 2D. So there's quite a lot of stuff in here. So I will need to cover most of it fairly briefly. I won't go too much into depth. But let's see here. First, I'm just setting up a different sort of health bar, which works better for 2D games. And then I have some overrides. So for attacking the victim, as you saw when I was playing, instead of playing an attack animation, you just have the pawn like sliding forwards and then back again fast when attacking another unit. So this is where this is set up. So a lot of the stuff is the same as in the regular toolkit. Let's see the differences. The rotation is different, so the entire unit doesn't spin. And you play this projectile sound when you attack something. The projectile sound can be set up to be something different for different units. And yeah, this is does the unit have a projectile or not? So that can be set up here. If it does, then it plays the projectile sound and it fires a projectile, which is launched towards the location of the unit that is attacked, the target location, using a timeline, and then simply setting the actor location and rotation of the spawned projectile towards the target. So that's fairly simple. And then the projectile is destroyed. So, but if it's a melee attacker instead, so if projectile is false, then it has a different timeline-based animation, or really a translation, where it sets the location of the current actor based on this timeline, which is a simple timeline where it just goes back and forth. Let's see, yeah, just back and forth like that, and it plays the hit sound in this case, which is the same for all units. And then it runs the receive damage event on the target, and afterwards it chooses the next pawn. So that this stuff is very similar to the regular unit parent tile. There are also some differences when the units are moving. They're not playing their animation. They're not following a spline. They are sliding from tile to tile, also using these sorts of timelines. So yeah, you can look into that. It's fairly easy to understand. I think if you have problems with it, just send me a message on the support thread. Then you have this special event, the search for item event. Let's see. So this is an event where when a unit has entered a tile, it will check if there is an item on that tile. Now the way it does this is to do a line trace directly downwards and seeing if it hits any actors, any items that are lying on the tile. So it checks, okay, did I hit an actor? Is that actor item parent, which I will go into later, which is the parent blueprint for all items? If it is, then it runs the activate item event, which is inside the item parent. I will go to that later. And this event can do whatever, which is defined inside whatever item is on the tile you are entering. So that can be an item like a potion or a sword, or it could be a trap or anything really. So it's a pretty simple way to set up these sorts of items, traps, and so on. Let's see here. Most of the other stuff is fairly similar to the regular toolkit, though there is some different stuff here. You have this reveal visible tiles event inside the grid manager 2D. So whenever the unit enters a tile, if that unit is the player unit, then it will, let's see, it finds the location of the current actor. It gets, okay, from the location I'm currently at, the hero is currently at, what index is it, what grid index is the actor at, the hero at, using this vector to index interface, which has been covered before in a different video. And then from this index, it reveals the visible tiles around that unit, which will always be the hero, using the sight range defined inside this unit. Let's see, that's the most important stuff here, so I can just show this real quick. So what is happening here is basically that from the index that the hero is currently at, we get all indexes in range using this basic function which is in the regular grid manager. And for each of the indexes outputted from this function, which are contained in the tiles in range array, we then want to check, are these, is the fog of war here false, which means it has not been revealed yet. If it does, then we might want to reveal it if it can be seen. And to check if it can be seen from the location of the hero, we do a line trace and we see if we hit any walls. And if we don't, then we remove that instance static mesh and we update the fog of war array appropriately. Let's see. And also at the end, we check through all of the tiles that we have revealed. We see if there are any units on any of them, any enemy units, and if there are, we want to add them to the initiative order so that they will now be fought. And for each of these units, we also set their current movement to 0. This is to have this, the first round that they are revealed, they will not move or attack, only afterwards. So that's why I added this. And then we set free roam to false so that we can no longer move freely about, but that we go into a turn-based combat mode. So let's go back to the event graph of unit parent 2D. That's that part. For the next, let's see, yeah, receive damage. Yeah, this one is basically identical to the one in unit parent, only that let's see, it uses the health billboard that I'm using here instead of the other health bar. So that's just a small addition, small change. Then we have the spawn blood on death. So that's pretty self-explanatory. When the unit is destroyed after running all of this, or we make sure to run all the nodes that we regularly do, but we also want to spawn a blood actor. So we just get the location the actor is currently on, or the locations of its sprite actor, which is the same thing, and we spawn an actor there. And as you saw in the blood actor, then it will then run the event begin play to choose a random blood sprite. Then we have this, yeah, this one says unused. This is if the unit is moving along the spline, we do not want to rotate the unit, we want to keep it always facing up. So yeah, initially I had them moving along a spline. I don't do that anymore. I use the different sort of step from tile to tile I spoke about earlier. But yeah, if you want to make a very similar 2D game and you want to have the units moving along a spline, you can use this stuff here. And it's just a small change to rotation, really. Moving on, we'll go to the next unit. So yeah, unit 2D sprite 2 is just child actor of unit parent 2D, just with the sprite component added. Just so that we can now make child actors of this unit, and they will always have a sprite component, so we don't have to add it every time. Let's see, so yeah, this is actually the parent class of all the monsters here, so everyone except for unit 2D sprite hero. So let's look at this guy first. He has a few additions. Just that when this unit is destroyed, we check what is the length of the initiative order. So is it equal to 1, which means that the only unit left is the hero. Since if the hero is destroyed, we run some different stuff. But so if there's only one unit left, then we set free roam to true. So that's pretty simple. And this is a small addition too. Every time this unit moves, it kind of shouts out to any nearby units and wakes them up if there are any nearby. So what we do is that we find the tiles in range of this unit every time it moves, and then it checks all the tiles in sight, and it checks if it finds any pawns from the pawn array, then it adds them to the initiative order. So this is just to wake up nearby units so they can also attack you. All these other units are just the same as the others, just child actors of the monster parent orc that just use different sprites and have different stats for health and move and so on. But the sprite hero is quite different. So we have some other things. It seems more than it is, because much of it is the same, just with some small alterations. So here we have at the beginning of play, we just let's see, get the tiles in range, or we reveal the visible tiles in range. So it's just the same thing that we do every step for the hero, just that we do it at the start of the game as well. And we also equip the dagger. Yeah, it's a bit hacky, but we try to find, are there any daggers in the game, and then we equip them, just so we have a weapon equipped from the start. So yeah, this dagger over here, I could have done that more elegantly, but it works. So yeah, this is the event for equipping items. It will be easier to discuss after we look at the item, I guess. But yeah, what basically happens here is that when we move on top of an item, equipable item such as a sword or a shield, it will activate this equip item event. And then we will check, okay, what is the item type? Is it a weapon? Is it armor? Is it shield? An item that is set to other should never try to activate this equip item event. So then we just send an error. But yeah, if it's a weapon, then we cast it to our weapon class that I've made, and we set the weapon variable of the hero to be the value of the weapon that we have just stepped on top of. And we also set the range of the hero unit to be the range that we get from this sword. And we set the sprite, the weapon sprite, to be the same as the sprite contained in this weapon. So yeah, to explain that, I'll need to show this hero, because he is made up of many different sprites. So one for the robe, one for armor, one for helm, shield, boots, weapon, and so on. So when we change this sprite, let's see here, different held sprites. Yeah, we change the sprite like so. Let's see. So that's what we're doing in the graph here. I'll get more into how this works when we go to the items. Then we have the attack victim event. It's very similar to the other one we just saw in the unit parent 2D, only that when we find out, we check if the weapon has a projectile or not. We check the weapon. Does the weapon that is equipped have a projectile or not? Not if the entire unit is set up to have a projectile attack, as is the case with the monsters. And similar, when we do damage, we check, okay, what is the damage of our weapon? So yeah, but other than that, this is the same as in all the monster pawns. Then we have received damage. This is also, yeah, it differs in that it's reduced by the hero's shield and armor variables. So as you can see here, when we are subtracting damage from the unit's health, we then subtract from that damage the armor value and the shield value, or the armor value of the shield and the armor value of the armor. So that's how that differs. And we have the destroy unit event. If the hero unit is destroyed, we want to end the game. So we go to the game mode, we set game over to true, we destroy the actor, of course, and we call to the dungeon HUD, and we want to run the game over event, which is a very simple event that just says the game over text to visible. Let's go to the next blueprint. So yeah, that's all of the units. If we now go to the items, which I was just talking about, so we have the item parent. This is a very basic blueprint, which has a sprite and which has the activate item event, which just by default prints no activate item event found. add event blueprint. So this is just a parent that is not used. We modify this event in the child actors. So for instance, we have the item door. This is pretty basic. So if the event activate item event is called on the door, what we do is that we first destroy a component. This box, this is just a box that blocks visibility. So that is so it is destroyed, and the visibility of the open door sprite is set to true, and the visibility of the closed door sprite, which is just called item sprite 0 in this case, is set to false. So the effect is that the door transitions from closed to open, and that you can see through it, and then we play the open sounds, and that's very basic. Then we have the item potion, which is also simple. We step on top of it, and then we see we cast to the hero, and we set the current health of the hero. We add the heal amount of this potion to the current health of this unit, being careful not to make it higher than the max health of the unit. And we play a potion sound, and we make sure to destroy the potion actor so we cannot drink it multiple times. So that's also basic. The torch trigger is a simple blueprint that is set to activate. Let's see, it's not that simple actually, but yeah, when we enter a torch trigger, so this trigger here is a torch trigger, so that we enter this, then we light this torch here using the light torch event in the torch blueprint. So why all this other stuff? Well, we are lighting one torch here, and we're also lighting a torch a different place in the level. That's just part of the game. And we also check, have all torches been lit? And if they have, then we want to spawn the bridges that are over the lava that I was talking about, and then we make those bridges passable. So that's how this works. Let's see. So the sword is the parent of all these other weapons. So they are based on this, just with different sprites. The sword is like this. It has a few values. It has a damage value, a range value, a projectile value. It has a class for the projectile it sends. It has a sprite for how it should look when it is equipped by the hero. It has a sprite when it's lying on the ground. And it has a few nodes. So just when it is activated, we check or we cast to the sprite hero, the activating unit. Then we equip the item, as you saw in the unit in the hero blueprint. We make this actor hidden. We don't want to destroy it since we're still referencing it. And let's see. Yeah, we're getting the grid manager. Let's see, what am I doing here again? Yeah, I remembered. We're clearing the range array so that when we equip the item, if we had a ranged weapon and now we have a melee weapon, we want to make sure that the range array, which as you recall from previous videos, contains what items can we attack from where we are currently standing. We want to make sure that we cannot then shoot with our sword for the first turn before we move, and the range array is naturally reset. So that's just a simple fix. And then we play the sound for it being equipped, which is the sound called Potion, which is the one I used. These are the projectiles. They are extremely basic. Let's see, they are all parented to this one. It doesn't have anything really, just as a paper sprite. So that's that item. Then we have the only shield and the only armor in the game. They are very similar to the sword and so on, as that we are equipping them, equipping the item, and so on. Yeah, making it invisible, very similar to the item weapon parent sword. Okay, so we've come quite far. Let's see, that's it for blueprints, I think. For other things, we have sounds. So I've made these sounds. You can use them freely. They're pretty basic though. Though here's the dungeon music by Jon Lunde. like I said, link to his other stuff below. Nothing more to say about the sounds, I think. Sprites, textures, tile maps. Yeah, these are based on the textures, so let's start with textures. This is the tile set, or the texture really, that I've gotten from this RL tile set, this amazing Creative Commons tile set. All of the tiles that are included are here. From this texture I've generated this tile set, which is of course identical, though here you can set up collision. So for all tiles that can be walked on, floor tiles, and for all tiles I want to block visibility, all the walls, I have enabled collision. Though for things like water, which you cannot walk on top of, but you can see past, does not have collision, for instance, and anything I don't need to have collision, I have not added collision. Let's see here. So yeah, so from this we get the tile maps. So here is the tile map base. So this is really where I just drew the entire dungeon. It's a piece of art, but yeah, so I don't actually use this. What I've done is that I've first made this dungeon here, and then I've duplicated it twice. One for the floor, everything that can be walked upon, as well as the water, which doesn't have collision, so that doesn't do anything really, and one for all the walls, which is this one. So why two different tile maps? So this is actually those two tile maps layered on top of each other. So why I've done this is that so I can set the tile map ground to block path trace, to designate all every tile that has collision on that tile map should be walkable, while the tile map walls does not block path trace, so they cannot be walked on top of. In addition, all of them block range trace, which means that you can't see through them. I've also made the collision of the tile map with the walls thicker than the collision for the tile map with the ground, so that when a unit attempts to see past it, it's actually thicker here in the z-axis, so that the line trace for visibility is blocked. So that's how I prevent being able to see through walls in this game. The same thing for these collision boxes that are on the doors before they are deleted when the door is opened. So let's see what we have left. Just the sprites. Yeah, these are just extracted from the tile map. Just some sprites and some flip books here. So I think that's everything actually. So my hope is that this example game can serve as an inspiration as to how you can use the toolkit to make a very different sort of game, different than a traditional turn-based strategy game. So this is just one example of what you can do, but there are many other possibilities, of course, with the toolkit. So just feel free to ask me in the support thread or in the comments below if you have any questions or have any specific sorts of games that you're wondering if the toolkit is suited for. Just ask me and I'll do my best to respond quickly. So that's it for this time. Bye bye.